Assalamualaikum. Today we will going to do exercise 3C from chapter 3, which is system of first order and second order equation. Okay, the equation is non-homogeneous. y1 equal to negative 3y1 minus 4y2 plus 5ex. y2 is given by 5y1 plus 6y2 minus 6ex. Okay, with the initial condition given, y0 equal to 1, negative 1. Okay, the first part we will find yc by doing the same step as the homogeneous equation. Okay, the first step is we will write in metric form y equal to ay plus g. We just get the a straight away, a and g straight away from here. Okay, this is a, negative 3, negative 4, 5, 6, y plus g. This is will be our g. Okay, settle the first step. The second step, we find the eigenvalue lambda 1 and lambda 2. Okay, negative 3 minus lambda, negative 4, 5, 6 minus lambda, we will equal to 0. And we will expand this time with this, and we'll minus this. Okay, and I get quadratic equation and substitute into the calculator, and I get lambda 1 is equal to 2 and lambda 2 is equal to 1. Okay, we proceed. Okay, for lambda 1 equal to 2, we will substitute the lambda into this equation and we will get eigenvector. Okay, I just substitute the lambda 1 equal to 2 here, and I get this equation, negative 5, negative 4, 5, 4, AB equal to 0, 0. Okay, we will assume let S equal to A, and we get this 1, negative 5 over 4S. Okay, we do the same step as the lambda 2 as well. Okay, I just substitute the lambda 2 equal to 1 here, and I get this negative 4, 5, 5, AA minus equal to B, 0, 0. Okay, and also I will let S equal to A, and I get 1, negative 1S. Okay, we proceed to the step 3. We will check the eigenvector. We have to check either the eigenvector linearly independent or not. Okay, since the equation is not equal to 0, it is mean linearly independent, so we just can proceed to the next step, which is general solution yc. We can straight away get the yc. Okay, I just substitute the eigenvalue here and the lambda 1 and lambda 2 here, and I will get the general solution for yc. And we have settled the first part, which is to obtaining the yc. Okay, we proceed to the part 2, finding yp. Okay, the first step, we obtain yp by assuming from g. Okay, this is our g, 5ex minus 6ex. Okay, by referring to the table, we get this u1, u2, ex. Okay, it seems like yp is same pattern as yc, so we have to times with x. So our new yp is u1x plus v1, u2x plus v2ex. Okay, at here yp is not equal to yc, so this is our new yp. Okay, we proceed to the second step, obtaining yp prime. Okay, we have to differentiate our yp. Okay, so I divided it into two parts, A and B. Okay, of our A, I doing product rule here and here, and I get this u1 1 plus x plus v1 ex. Okay, it is same pattern as the B. I'm applying product rule as well, and I get u2 1 plus x plus v2 ex. Okay, so this is our yp prime, u1 1 plus x, v1, u2 1 plus x plus v2 ex. Okay, we just proceed to the next step, which is we will compare yp prime that we get from previous step with y prime that from ayp plus g. Okay, this is our yp prime, and this is our y prime, which is this is a, this is y, and this is g. I just substitute the yp here, and I expand the equation, and I get this. Okay, and I will separate the equation according to the coefficient here, ex with dx and x ex, so it is easier for us to compare the coefficient. Okay, we start compare the coefficient. I just start with x ex. Okay, this, since there is no x ex from the right hand side, so we just equal to 0. Okay, I just bring the u1 into the right hand side, and I get this equation, these two equation. Okay, next I will assume u1 equal to s, so we just change the u1 with s and get u2 equal to s, and we can assume that u1 u2 equal to s negative s, which means 1 negative 1 s. Okay, for the ex, there is ex coefficient on the both sides, and I get this equation, u1 plus v1 equal to negative 3 v1 negative 4 v2 plus 5 v2 plus u2 5 v1 plus 6 v2 minus 6. Okay, this is a and this is b. Okay, for a, let's look at the a first. u1 equal to negative 4 v1 minus 4 v2 plus 5. Okay, I just bring the v1 to the left hand side and settle it down, and also we will assume u1 equal to s as the previous. Okay, and from this equation we can get the v1. Okay, we proceed to the b. I just substitute the v1 that we get from a into the b, and this simultaneous equation, we will cancel out the v2 and just left the unknown s here, and I get s equal to negative 1 over 9. We look back at the x, which is u1 u2 1 negative 1s. Okay, we also substitute the v1 here and get s equal to 1. Okay, our yp new is u1 u2x plus v1 ex. Okay, we just substitute the u1 equal to s equal to 1 and u2 equal to negative s equal to negative 1 here, and we get the same equation, v1 plus v2 equal to 1, v2 plus v1 equal to 1. Okay, we will replace v1 with s, and we get the value of v2, so we get v2 equal to 1 over s here. So we write in metric form, v1 v2 s 1 minus s. Okay, so this is our yp new in 181 sx plus s 1 minus s ex. Okay, I just substitute the s here and we get this yp new. This is our yp new. Okay, we just proceed to the step 4. We get general solution by this y equal to yp plus yc. Okay, we just combine the yp that we get from the second part and yc that we get from the first part, and we get our general solution. Okay, since there is initial condition given in the equation. Okay, this is our initial condition given, y0 equal to 1 negative 1. We can read it as this, x is our 0, y1 y2 is y, and negative 1. Okay, I just substitute the initial condition into the general solution, since e exponent equal to the power of 0 is equal to 1. Okay, so we just can simplify the equation into this, and we'll get C1 plus C2 equal to 0, and 5/4 C1 plus C2 equal to 1. Okay, we'll just substitute into the calculator and get C1 equal to -1 and C2 equal to -4. Okay, since we get our C1 and C2, we just substitute back into the general solution, and we get this. I just simplify here because it is have same term here, so we can just plus and get our solution. Y equal to 1 -1x plus -3 4 ex plus 4 -5 e2x. So this is our solution to our exercise 3C.